Friction and viscosity. Friction is the force that opposes the relative motion of two solid surfaces in contact. Limiting friction is directly proportional to the normal reaction. We use F for limiting frictional force, capital letter R for normal reaction. The normal reaction in this case is equal to the weight of the body. So frictional force is equal to a constant times normal reaction, or we say it's equals to the constant times mass times acceleration due to gravity. The constant mu is called the coefficient of limiting friction. It is the ratio of the limiting frictional force to the normal reaction. Friction makes writing possible. It helps to bring cars to a stop, and among other things, it makes grinding possible. Friction causes overheating of engines. It causes wear and tear of surfaces. It also reduces efficiency of machines. For a body resting on a plane inclined at angle theta to the horizontal, when in equilibrium, the forces that keep it balanced are its weight, the normal reaction, and the force acting parallel to the plane. This is a body of mass M resting on this plane inclined at angle theta. At equilibrium, there are three forces that keep it balanced. The normal reaction, which acts perpendicular to the plane, represented by R. The weight of the body itself, which acts vertically downwards. And the force acting parallel to the plane, F subscript P. To determine the three forces, the values are shown below. Weight is equal to mass times acceleration due to gravity. The normal reaction is equal to mg cos theta, while the force that is acting parallel to the plane is mg sin theta. Friction between solid surfaces can be reduced by 1. Lubricating the surfaces. 2. By use of rollers and ball bearings. 3. By streamlining the surfaces. Viscosity or viscous force is the force that opposes the relative motion of layers of fluids or relative motion of a solid and a liquid or gas. The magnitude of the viscous force depends on the nature of the liquid, the temperature, among others. Viscosity does not depend on normal reaction. For a body falling through a viscous liquid, three forces act on it. These are its weight, represented by W, the upthrust U of the liquid on the object, and the viscosity V of the liquid. This is a simple illustration. Upthrust is upward. Because the object is falling inside, the force that opposes its relative motion with the liquid is viscosity in upward direction again. Then the weight of the object is vertically downward. An example of such a viscous liquid is glycerin. The falling solid object through the viscous liquid first accelerates. At that time, the weight is greater than the upthrust plus the viscosity. It accelerates until it reaches equilibrium At equilibrium, it moves at a constant or uniform velocity, called terminal velocity. Here is the graph that illustrates the motion of a small solid object like a ball bearing through a viscous liquid. First, it accelerates and then moves at constant or uniform velocity, called the terminal velocity. At terminal velocity, the weight of the object is equal to the sum of the upthrust and the viscosity. Note, for an object resting on an inclined plane whose angle of inclination to the horizontal is theta, the coefficient of friction is obtained by finding the tangent of the angle. Coefficient of friction is equal to tangent of the angle of inclination or the angle of friction. Example 1. We have a brick on a surface pulled through a cord in the right direction. A brick at rest on a horizontal table is pulled by a horizontal cord as shown above. The force of friction on the brick A increases if the pull increases, but the brick does not move. B is directly horizontal to the right. C decreases if an identical block is placed on the first. D changes if the brick is turned on its side. The correct option is A. Option A is correct because the force of friction increases with the increase in the force applied to move the brick forward. Option B is not correct. B is not correct because the direction of frictional force is opposite to that of the applied force. Because direction of friction is opposite direction of applied force. C is not correct because an increase in the weight of the brick will result in the weight of the brick means an increase in normal reaction. And frictional force is directly proportional to normal reaction. So the frictional force ought to increase if the normal reaction increases. D. The force of friction will not change if the position of the brick is changed because friction does not depend on the area of the surfaces in contact. This is not correct because friction does not depend on the area of the surfaces in contact. surfaces in contact. Example 2. The coefficient of static friction between a 40 kilogram crate and a concrete surface is 0.25. Find the magnitude of the minimum force needed to keep the crate stationary on the concrete base, inclined at 45 degrees to the horizontal. Acceleration due to gravity is 10 meters per second square. And the options are A, 400 Newton, B, 300 Newton, C, 283 Newton, and D, 212 Newton. The solution to the problem is as follows. The crate is placed on a concrete surface that is inclined at angle 45 degrees. Here's the concrete surface. The angle here is 45 degrees. And we have our crate here. Now, the force of friction is this way. Frictional force, which is coefficient of friction times normal reaction. We still have a force acting parallel to the plane. F parallel to the plane. And we have the formula for each one. To maintain this crate, this is the crate here, in this place, we need an additional force, upward force in this direction. Because the force acting parallel to the plane definitely is greater than the frictional force. So that this crate does not slide downwards. So first, let's calculate the force of friction. Frictional force is F, which is coefficient of friction times normal reaction. Coefficient of friction times the normal reaction for a body inclined in a plane like this is mg cos theta. So the friction will be 0.525 times 40, the mass of the crate, times acceleration due to gravity, cosine of angle 45. By the time we finish the calculation, we end up getting 70.7 Newton as the force of friction. Now, force acting parallel to the plane, acting to the plane is Fp. Fp is mg sine theta. Fp will give me 40 times 10 times the sine of 45 degrees. This will give us 283 Newton, the force acting parallel to the plane. So the difference between the two forces is the minimum force needed to keep the crate stationary. The force required to keep the crate stationary is F. Fp must be equal to frictional force plus F. 283 is equal to 70.7 plus F, the required force. So the force required is 283 minus 70.7, which is approximately 212 0.3 Newton. Option D is correct. Example 3. An object of mass 80 kg is pulled on a horizontal rough ground by a force of 500 Newton. Find the coefficient of static friction. Option A, 0.84. B, 0.63. C, 0.54. And D, 0.32. We are given the mass of the object as 80 kg. Therefore, the weight, which is mg, will give us 80 times 10. 800 Newton as the weight. This weight is equal to the normal reaction. Therefore, the reaction is 800 Newton. The force that pulled the object horizontally is equal to the frictional force. Frictional force is 500 Newton. Coefficient of friction is the ratio of the frictional force to the normal reaction. Therefore, coefficient of friction is 500 over 800. 500 divided by 800. When we do this, we end up getting 0.625, which is approximately equal to 0.63. Therefore, option B is correct. Example 4. When the brakes in a car are applied, the frictional force on the tires is A disadvantage because it is in the direction of motion of the car. B, a disadvantage because it is in the opposite direction of motion of the car. C, an advantage because it is in the direction of motion of the car. D, an advantage because it is in the opposite direction of motion of the car. Option A is not correct. A is not correct. Why? Because friction is not in the direction of motion of the car. Friction opposes the motion of the car. Because friction opposes the motion of the car. Option B is also not correct because if friction is in opposite direction of motion of the car, then it's an advantage. C, an advantage because it is in the direction of motion of the car is not correct. Friction is not in the direction of motion of car. Option D is correct. It's an advantage because friction being in opposite direction to the motion of the car helps to bring it to a stop. Option D is correct because the opposition to motion of car by friction helps to stop it.